Hello and welcome students once again to another video class for grade 8th mathematics, and today we'll be starting our new chapter, that is chapter number 16, playing with numbers. And today we'll be understanding some very interesting concepts regarding numbers, and as well as some games related to this, as well as some puzzles that we can understand in this chapter. So let's begin with this. So basically, mathematics is a subject which is full of fun, magic, and wonders. So in this chapter, we are going to experience some of this fun and wonder, and we'll also learn the method of writing a two-digit number as well as a three-digit number in its generalized form, and to find out the divisibility test rules for numbers such as 2, 3, 5, 9, 10, and 11. So basically, in this chapter, we'll learn about the generalized representation of numbers, either two-digit or three-digit. Then we'll check for some puzzles and games related to that. And further, we can proceed to test of divisibility in our next video class. So let's begin with this. So basically, numbers in general form. First heading is numbers in general form. So first of all, we'll understand that how we can represent a two-digit number as well as a three-digit number in its generalized form. So for example, let's take a number 42. So if we reverse its digits, then we'll get 24. Okay. So basically, the number which is given to us, that is 42. But if you will reverse the digit, then what becomes? The units place digit goes to tens place, and tens place digit is swapped by units place digit. So basically we'll get 24 in that case. So if 42 I want to write in this form, then I can write like this also. That is 4 into 10 plus 2 into 1 is equals to 10 into tens digit plus ones digit. Okay, similarly 24 also you can write like this. That is 2 into 10 plus 4 into 1. So basically 10 is multiplied by tens digit, and we have to add ones digit in that to get any number. So for example, in the same way, for any two-digit number, the rule is, for example, if any number AB is there, so AB we can write like A into 10 plus B into 1. Similarly, if you want to reverse the digit, then you will get the number BA, and BA you can represent like B into 10 plus A into 1, right? So hence, the rule that we got is any two-digit number whose tens digit is A and units digit is B can be written as 10 into A plus B, okay? Where A is not equal to 0 and B is a whole number. So basically, these two things you have to keep in mind, that any two-digit number of the form AB, where A is the units digit and B is the tens digit, okay? So sorry, A is the tens digit and B is the unit digit. So we can write like that, 10A plus B. Okay, similarly for BA, we can write 10B plus A, but you have to keep in mind that A should not be equal to 0 and B is a whole number. So hence we can observe that AB is not equal to BA. For example, 42 is not equal to 24. Right. So similarly, now for a three-digit number, let's see how we can write a three-digit number in its generalized form. So let us take a number 142. So 142, you can write 1 into 100 plus 4 into 10 plus 2 into 1. And similarly, if you want to reverse it, then the number that after reversing the digits we'll get, that is 241. Okay, 4 will remain in the middle position as well, but only the position will change for hundreds and ones digits. So 142, after reversing the digit, you will get 241. So 241 you can write 2 into 100 plus 4 into 10 plus 1 into 1. Okay. Similarly, let us take any number ABC. So ABC is any number, for example, 142, and CBA. Okay, so after reversing the digits, you will get CBA, that is 241. Okay, so ABC is not equal to CBA, right? So let us consider another example. For example, let us take a number that is 712, 712. So this 712 in its generalized form, you can write like 7 into 100 plus 1 into 10 plus 2 into 1. Why we are doing this? Because you know that 7 is at the hundreds place, and 1 is at the tens place, and 2 is at the units place. That's why we are writing like this. Okay, then after reversing the digits, we'll get 217. So 217 you can write like 2 into 100 plus 1 into 10 plus 7 into 1, right? So here we can see that ABC is equals to 712 and CBA is equals to 217, okay? So ABC is equals to A into 100 plus B into 10 plus C into 1. Okay, and CBA we can write C into 100 plus B into 10 plus A into 1. So these two representations are the generalized representations for any three-digit number. So ABC is any given number, and if you are reversing that number, reversing the digits, then we'll get CBA. So both these numbers you can represent like this in its generalized form, right? So we can see that a three-digit number whose hundredths digit is A and tens digit is B and units digit is C can be written as 100A plus 10B plus C, where A is not equal to 0 and B and C are whole numbers. Okay, so that is the rule. So now let's start with some number games. Okay, few number games we'll see, and it is one interesting concept that you should understand, and you can just look it around. Okay, so first number game that we'll see, okay, first type of number game. So these are the following steps or rules that we have to follow in order to understand these number games. So first step is take any two-digit number. Okay, this is the first type of number game that we are going to understand. So first of all, then we have to take any two-digit number, then add the reverse of the two-digit number to the number itself. Okay, then third step, C, divide the number by 11. Then D is the final result that you will get. You will observe that there is no remainder left. So this rule, okay, or this number game is valid for any two-digit number starting from 10 to 99. So any two-digit number you can take and follow these steps and you will get the same result, okay? So for example, let us take a number. Okay, I am taking a number. Let's say it is 24. Okay, then by second step, what is the second step? Add the reverse of the two-digit number to the number itself. So reverse of this number is 42. So what I have to do, I have to add 24 plus its reverse, that is 42. So 24 plus 42, let's see, we are getting that is 66. Okay, so after adding this we are getting 66. Now third step is divide the number by 11. So 66 by 11, what you will get, that is 6. So which we can observe that the remainder is 0, or we can say no remainder is left. Similarly, you can follow the same number game, or you can follow the same steps for any two-digit number. For example, let us take 51. So 51 number I am taking. Okay, now let's say that 51 I have to reverse. So after reversing, I'll get 15. So 51 plus 15, how much you will get? That is again 66. Okay, so 51 plus 15 again got 66, and again divided by 11, we'll get no remainder left. Now another number we can take. For example, let us take 13. So if I am taking 13 number, so after reversing it, what you will get? 13 plus 31. Okay, 13 plus 31 is how much? That is 44. So again you are getting a number which is divisible by 11, which means that no remainder is left. So any two-digit number you can take and try these rules, and you will get the same result, that no remainder is left. So now second type of number game is these are the rules that we have to follow in order to understand this number game. So for example, let us take any two-digit number and now reverse the digits of the number and subtract the number from the larger one, and now divide the answer by 9. You will observe that no remainder is left again. So let us take an example, and we have to follow all these four steps to understand this second number game. Okay, so for example, I am taking a number 10a plus b, because as I told you that any two-digit number in its generalized form we can write like 10a plus b, where a is the tens place, or we can say tens digit of that number, and b is the units digits. For example, in this case, we are taking the number 10a plus b, and let a is equals to 5 and b is equals to 3. So number becomes 10 into 5 plus 3, that is 53. Okay, now second step, reverse of this number will be 10b plus a. Okay, because reverse, in case of reverse number, the units place units digit becomes tens. Okay, so we will get 10b plus a, so number becomes 35. Now third step now is, now in the second step we have to reverse also, and we have to subtract the smaller number from the larger one. So let's see how we'll subtract. Okay, So 10a plus b was the larger number. As you can see in this case, 53 is the larger number. That's why we are subtracting the smaller number, that is 10b plus a, from the larger, that is 10a plus b. So after subtracting, let's see what we are getting. 10a plus b minus 10b plus a, which means that it is nothing but 53 minus 35, that is 18, that is 9 into 2. So let's see what we are getting. So 9a, after you subtract 10a plus b and open the brackets and multiply in this minus sign into the bracket, you will get 10a minus a. That's why we are getting 9a. Similarly, plus b minus 10b. So plus b minus 10b, you will get minus 9b. So basically what we are getting, 9a minus 9b. Now 9 you can take common, and in brackets you will get a minus b. Okay. So which you can see that it is a multiple of 9. Got it? So after subtracting that number from the smaller number from the larger one, you will get a number. Okay, now divide the answer by 9. So as again, you can see that no remainder is left, because that number what we are getting is always a multiple of 9. Okay, so this was the second number game, and you can check this concept for any two-digit number. The answer will remain same. You can take any two-digit number and then reverse the digit, then subtract the smaller one from the larger one, then whatever the answer you are getting, you have to divide by 9, and you will see that the remainder will be 0, or we can say that no remainder will be left. Got it? Okay, so last step, you can see that we are getting this one. Okay, so we'll get only quotient, no remainder. Now we'll proceed to third type of number game. So in this, we have to follow these steps. The first one is that it is a number game regarding three-digit number. Okay, so first of all, we'll take any three-digit number. Let's say now reverse the digit of that number. Then third step is subtract the smaller number from the larger one. Okay, then whatever answer you are getting by 99, you have to divide that. Then you will see at last that you will observe that no remainder is left. So this concept and this number game is valid for any three-digit number. So previously we have seen two number games that were for two-digit number, and this number game is valid for any three-digit number. Okay, so we'll take an example to understand that what we can do over here. Okay, so let's take an example. So consider a three-digit number. For example, ABC is the number where A is at the hundreds place, and B is the tens digit, and C is the units place. Okay, so we can write like that number as 100A plus 10B plus C. Okay, now let's take an example that if A is equals to 2 and B is equals to 3 and C is equals to 4, so the number is 234. Okay, now next step, to reverse this number. So after reversing, what you will get, CBA. Okay, the actual number is ABC, but after reversing that second step, you will get CBA. So CBA will be what? That is 4-3. We are having 432. Okay, so after reversing, let's see what we are getting. That is 100C plus 10B plus A. So B will remain at the same place, only the positions of A and C will interchange. Okay, so the number that we are getting, 100C plus 10B plus A, that is 432. Okay, now step number 3, subtract the smaller number from the larger one. So basically what we are doing, we are subtracting the smaller from larger one, that is 100C plus 10B plus A in one brackets minus 100A plus B plus C. So after simplifying, let's see what we are getting. Okay, so basically the number that you will get in this case, in this example, that is 198. But for any possible number, any possible three-digit number, you can apply this rule, and you can see that this number game is also valid for any three-digit number. Okay, because after simplifying, let's see what we are getting. Okay, so 100C minus C. Okay, basically you will get what? 100C minus C, that will be 99. Okay, similarly again you will get 99C, and you will get for A, again you will get minus 99A, and for C you will get also 99. Okay, so whatever answer you are getting after subtraction, you will see that whenever you will divide that by 99, always you will get no remainder. Okay, so this was the third number game. Now we'll see the fourth type. Okay, so it is also based on a three-digit number. So let us consider any three-digit number. For example, 100A plus 10B plus 1C. Okay. Then second step. So for example, let us take ABC is 234. Now use this number to form two more three-digit number. That is, the first number is CAB. So it is mentioned wrong over here. You have to write CAB. So first number is CAB and the other number is BCA. So for example, I am telling. So the number is, if the number is ABC, so if the number is ABC 234, then two more numbers you have to form using this number. So first number, that will be uh, CAB. Okay, keep it CAB. So CAB will be 423, right? And the next number that you have to make, that is BCA. Keep in mind, BCA and CAB only you have to make. So CAB will be 423 and BCA will be 342, right? Now add the three numbers ABC plus CAB plus BCA and divide the result by 37. Okay, so this is the fourth type of number game. So as the addition of 234 plus 423 plus 342 is 999, and if you are dividing this result by 37, you will see that no remainder is left, which is you are getting 27 as the quotient. Okay, so you can try this number game also for any three-digit number and you will get the same result. Okay. So this was all about the number games that we discussed, four number games in this video class. And now we'll discuss the next concept, that is letters for numbers. Okay. So all of you have to practice at least two examples on each of the number games. So first two we discussed, that was about two-digit number. So you can take any two-digit number and follow the same steps, and you will see that that number game is valid for any two-digit number. And similarly for the last two number games, third and fourth one, that you can take any three-digit number and apply the same rules, and you will see that that two number games for three-digit also is valid for all three-digit numbers. Okay, so now let's proceed to letters for numbers, right? Yeah. Okay. So the rules for letters of numbers, first of all, we have to understand what are the rules. Okay. So we'll start with that. So basically, these are nothing but puzzle type of questions that is a bit interesting also regarding numbers. Okay, so basically we'll solve some puzzle type questions based on this concept that is called as letters for numbers. So basically, these are puzzles in which letters takes the place of digit in an arithmetic sum. Okay, and the problem is and the problem is to find out which letter represents which digit. So it is like a cracking a code. Okay, so maybe you have gone through such type of questions in some puzzles if you have solved. Okay, so not, if you have not, then we'll see now. So for example, basically you have to understand the basic rules for such type of puzzles to solve. The first rule that you will see is over here, that each letter in the puzzle must stand for just one digit, and each digit must be represented by just one letter. Okay, and the second rule is the first digit of a number cannot be zero. So these two rules you have to keep in mind while solving such puzzles. So let's take an example to understand and to get a better idea regarding such type of puzzles. So for example, this is the question and you have to find the value of r in the following addition, right? So this is the arithmetic sum is given to you. So you have to find the value of r. So solution, you can see it over here, and you can solve it on your own also. So here you can see that there is only one letter r which we have to find. So now all of you can see that at units place in the answer we are getting 8. Okay, so what should we put at the place of r to get 8? So r plus 3 is equals to 8. So basically the only number which is valid, which is validating this equation is 5. So basically our answer is 5. Okay, so r is equals to 5. Okay, then second, if r is equals to 5 we are taking, then 1 plus r is equals to 6 is also valid. So which means that our answer is correct. Okay, so the only possible value of r is 5. So hence 21r plus 1r3 is nothing but 215 plus 153, that is 368. Okay, so this was the first easy example. Now let's take one more example. in which you have to find the value of a in this subtraction. Okay, so the given question is a7b 398. Okay, so basically you have to find the values of a and b. So first of all, we'll start with the units place. So units place, you can see that in the answer we are getting 7. Okay, so which means that something we have to subtract from b. Okay, from b we have to subtract 8 to get 7. So b has to be 5. Okay, why b has to be 5? Because only 15 minus 8 will give us 7. So b should be 5. Okay, so how we can get 5 over there? But if b is 5, then we have to take one carry over from 7. Okay, that makes it 15, and then we'll get 15 minus 8 is equals to 7. So the value of b should be 5. Okay, why is it 5? Because 15 minus 8 is equals to 7, and one carry over we are taking from 7. So b has to be 5. Okay, that's clear. Now we have to find the value of a. Right. So all of you can try it yourself. Otherwise, you can see it over here. So now 6 is left at 10th place. Okay, because we took one carry over to B. So now 6 is left at 10th place, and one carried from A makes it 16. So basically we cannot subtract 9 from 6. So we have to take one carry over from A. So after taking one carry over from A, the number becomes 16. Now basically you can see that 16 minus 9 will give us 7. So which means that the value of C is what? The value of C is 7. Okay. So now as you can see that we took one carry over from A also. So what we subtract, what should we basically on subtracting 3 from A, we should get 4. So basically the value of A will be what? Okay, all of you can guess. Because we took one carry over, so the value of A will be 8. Okay. So this was the final step to find. So the number that we got is 875 minus 398 is equals to 477. You can practice some more questions of this type to understand and to get a better idea. And we'll solve some more questions in our coming Zoom sessions also. So now let's take one more example to understand some more queries regarding this. This third example, you have to find the value of in the following. Okay, the first one, you have to find 1a multiplied by a is equals to 9a. So what is the value, possible value of a in this case? Okay, you can just give a try. Otherwise, you can refer to the solution. So for A, we can check, for the first case, we can check various numbers starting from 1 to 9, that which number is satisfying this given calculation. So basically, you will find that no number other than 6, no number other than 6, I repeat, is satisfying this equation. Okay, is satisfying this basically this calculation. So basically 16 into 6 only will give us 96. No other number is valid for this question. So basically we got the first answer, that is A is equals to 6. Now let's solve for second question. We have to find the value of A, B, and C as well. So in second case, you can see that we are multiplying 3 into b to get b again. So what number should we multiply in 3 to get the same number back? So basically two possible solutions are there. Either b can be 0 or b can be 5. Okay, because if you will multiply 0 into 3, you will get again 0, and if you multiply uh, 3 into 5, again you will get 5. So basically we have, for b we have two options, either 0 or 5, but you can see that 5 is not possible because we are doing this multiplication for 2 digits into 3. Okay, so the 5 is not possible in this case, so only we'll take the value of b as 0. So if b is equals to 0, and you have to just consider that which numbers, if b is 0, then which numbers will give us the correct value of a and c. So you can observe that if we put the value of a as 5 and the value of c that we'll get is 1. Okay, so basically the number that we are getting, a is equals to 5 and b is equals to 0, that is 50. So 50 multiplied by 3 will get 150. Okay, so this is the final answer that we'll get. So hence 50 into 3 is 150. So students, this type of questions you have to understand, and such type of puzzles and number games you can solve on your own also. And this was all about this session, and we'll continue with more interesting questions in our coming Zoom session. So till then, try to practice these questions from your examples and textbook, and go through this video class at least once or twice so that you can understand the better of it. Okay, that's all from my side. Take care. Assalamu alaikum to all of you.